Assalamualaikum and good morning to my friends. My name is Muhammad Syakir bin Muhammad Farid, uh, and I am from Group 9. The topic that I will talk about today is controlling electricity optimization using Edge AI IoT supported by blockchain technology. Okay, so for the introductions, the problem for this topic is the legacy centralized energy grids are rigid, unsustainable, and cannot adjust to fluctuating consumer demand, leading to massive energy waste and instability. Okay, the hurdles for this topic is conventional systems suffer from critical data latency, which is time delay, and severe security vulnerabilities. The solution for the hurdles is a decentralized tri-layer technology framework, such as IoT sensor, real-time ground monitoring and telemetry, Edge AI, localized data processing for near-instant responsiveness, blockchain, secure, immutable auditing, and trusted peer-to-peer energy trading. Okay, so this project goal is to analyze current grid malfunctions and demonstrate how this integrated technology optimizes power usage while addressing privacy, compliance, and sustainability risk. That's all from me. Forward to the next presenter.
I would like to thank the previous presenter. My name is ATHAVAN, metric number 078577, and I would like to present our problem description. First of all, as you can see, monolithic grid is when traditional grids that previously used to rely on centralized model of legacy grid where powers only follow in one single direction from plant to consumers like residential areas and so on, ignoring modern bidirectional needs where energy cannot only flow in one direction but needs to follow in two directions at once to be more efficient. Next is data bottleneck. As you can see, long distance transmission causes energy waste, while centralized cloud processing triggers severe latency and grid instability, meaning that traditional grids, like the previous monolithic grids, cannot actually handle centralized cloud because it causes severe latency when the data is transmitted. Basically, it would not be fast since it only relies on moving on single direction. And since the infrastructure is old, the grid is also unstable. Next is prosumer waste. Monopoly schemes that locks user into low rates, causing clean solar power to be completely wasted due to a lack of local peer-to-peer coordination. Basically, when utility electrical companies monopolize the scheme where they buy clean energy from consumer that produce them, and they buy it at very low rates at a fixed market price. So at the end of the day, you cannot make profit from it, and there's no incentive to do so when you have to spend a high upfront cost setting up solar panels, batteries, and so on. Moving on to the next part of our problem description is stakeholder imbalance. The first stakeholder is prosumer, where the prosumers are the ones that who take the initiative to set up solar panel equipment and battery equipment to produce clean energy for their own use or to trade. However, they are still trapped by the monopoly, by the middlemen of electrical utility companies and their buyback scheme where they have to sell their energy at a fixed rate without get being able to get any sort of profit whatsoever. Next is consumers who suffer from retail price hikes driven by transmission overhead and surge pricing from inefficient central utilities. So basically, these are the regular people who live in residential areas that have to pay for electrical price hikes, especially because they are utilizing the infrastructure, the electrical grid. So yeah, they have to pay for that as well. and they suffer the most in terms of price charges. Next is utilities and operators. These are the people that manage our electrical grids and the utility services like the power station and so on. They manage the bidirectional loads in the old grid, which sometimes causes transformers to overheat and increase the neighborhood risk of experiencing brownouts. Last is regulator. These are the government enforcer where they are caught between strict carbon mandates and aging infrastructure that cannot safely absorb fluctuating renewable spikes. Basically, if you generate energy using solar or wind, the imbalance and the power fluctuation is not something that the old infrastructure electrical grids can actually handle. Moving to technical analysis, as you can see, this is our four-layer architecture. The main purpose is for decentralization, moving our data processing and power trading from slow centralized cloud to a fast local neighborhood energy trading. As you can see, starting with the first layer, we have physical slash IoT layer. These are our three equipment: solar photovoltaic panel, home batteries, and EV charger. And we use this smart meter gateway to act as a data hub that can uh, stream how these devices work in real time and upload the data straight to the smart meter gateway. Security wise, the gateway is cryptographically signed the data, meaning that the data is marked with a digital signature to immediately say that they cannot be tampered with. Next is our second layer, which is decision engine layer, our edge AI, which serves as the brain uh, that does not send data back to cloud server and instead just make its own decision on edge, on the spot, and predicts energy shortages in less than a second, as well as surpluses of energy. Let's just say that if it detects a 2.3 kilowatt per hour solar surplus coming up within the next 5 seconds or whatever, the AI will automatically schedule the same, and the human does not need to interfere whatsoever. And all you have to do is just click on it from app on your phone. Moving on to our third layer, the transaction layer, where all these stakeholders are able to purchase the energy using smart contract on a ledger system. When the trade is ready, the AI connects using secure APIs, application programming interface, to private high-speed permission blockchain network like Energy Web or Hyperledger. The ledger itself connects to all these type of customer, consumer, and so on. And the utility company acts as a validator for this exchange. And smart contracts that are automated programs without any bias to the market rules would help customers for a better energy purchasing experience. Layer 4 is our utilization and settlement layer. As you can see, the final billing reconciliation, green infrastructure optimization, and post-human consumer wallet app, where easy billing means everything is permanently locked on the blockchain itself. The records cannot be tampered with no matter what, and is sent to the neighborhood on the fly. I meant that the utility company can collect its billing fees for the grid infrastructure without any double billing errors. For the infrastructure optimization, operators can use the non-temperable record of the bill of the smart record and balance the neighborhood energy supply and track at the energy flow on the fly, keeping record over everything. Lastly, the end users, basically all the consumers here, are able to interact with the blockchain via simple mobile app or e-wallet to conduct their payment transaction. Basically, prosumers that consume the electricity basically and that generate the electricity are able to see an approximate of 28% increase in revenue for their clean energy production, and the neighbors themselves see a 12% decrease in the electricity bills. That's all.
Thank you to ATHAVAN for his presentation. Now I will be presenting the proposed solution to our project. So for the proposed solution, we have the technical framework. Our project would be using a 4-layer integrated grid topology. For the first layer, we will be using physical IoT. The parts would be the telemetry from the solar PV, the batteries for keeping the power, and EV chargers for any electrical vehicles that users would have. For the second layer, we would be using the Edge AI. The Edge AI would be the smart gateway to execute the predict and bid logic locally. For the third layer, we would be using a blockchain layer. We would have a permission network that pass and record peer transactions that happen throughout. For the last layer, we'll be using Discom that acts as a validator for any compliance and billing. Now, for this framework, the latency optimization that we have done is by shifting compute from central clouds to localized edge devices. This would cut any communication delay to sub-second levels, which means that we would reduce any communication as fast as possible to further boost the communication between the networks. Other than that, the traffic efficiency, by using a localized edge pre-processing, we would eliminate any web traffic bottlenecks over central communication nodes. This would mean that each node would have a much faster flowing traffic, as any dirty data would be cleaned and processed. And now for the proposed solutions, which is the automation and justification for the chosen framework. For our automation, we would be using smart contracts. We would be pairing the seller surplus bids with local consumer constraints automatically. This would make sure the seller would always have their own consumer without manually having to search for them. Now, we would also be using the asset validation by auditing our hardware signatures to verify for any renewable green technology and its origin. And we would also be using a tokenized settlement, which would mean that we would be able to bypass any banking fees as we are using Ethereum, which would mean that we will have an immediate financial clearing on-chain. Now, I have listed out the performance metric based on the research that is done in 2026. The research results in a additional 28% in revenue increase and a minus 13% in cost reduction, which would prove that both prosumers and neighborhood consumers would have a financial gain and reduce their losses. Now, for the physical grid longevity of this project, we would be using a loss mitigations, which would mean that we would balance the loads locally, so the electrical line would not be degrading as fast and cause any more losses. We would also be flattening the peaks, which would protect the transformers and battery banks from overheating and causing demand spikes from an over amount of users or consumers. That is all from me.
Moving into our risk and ethical considerations, we have identified 5 primary challenges within this implementation. First, shifting computation to thousands of distributed edge devices inherently expands our grid's physical attack surface. To prevent malicious tampering, our system enforces hardware-isolated trusted execution environments right within the meter gateways. Second, continuous telemetry tracking creates privacy risks by exposing granular consumer behavioral habits. We resolve this by processing raw data strictly at the local edge, utilizing zero-knowledge proofs to clear threats completely anonymously. Third, regarding environmental metrics, public mining protocols conflict heavily with sustainability targets. We completely bypass this constraint by deploying an eco-friendly proof of authority permission ledger. Fourth, looking at regulatory compliance, legacy utility rules lack the legal structures to clear direct peer-to-peer financial trading. To overcome this, our system runs within isolated regulatory sandboxes, integrating traditional utility companies directly as validator nodes to safely track and enforce legal compliance rules on chain. Finally, to bridge the social-digital divide, where lower-income families are locked out by initial equipment costs, we leverage the utility node to actively capture and redistribute localized power surpluses at inclusive subsidized rates. In conclusion, our technical investigation demonstrates that shifting from outdated centralized frameworks to a decentralized, 4-layered ecosystem eliminates cloud processing bottlenecks and reducing data latency to sub-second levels. Empirically, this integration minimizes physical grid congestion while driving a proven 28% revenue gain for local prosumers and a 12 to 13% electricity cost reduction for neighborhood consumers. As a critical team reflection regarding our required digital skills, we work collaboratively by integrating our digital tools to accomplish this task. We use Google Doc as our cloud workspace for real-time document creation, WhatsApp for immediate group discussion and milestone delegation, and Canva to design this sleek slide and format our final video layout. Moving forward, we formally recommend that national regulatory commissions modernize energy grid frameworks to legally permit peer-to-peer trading markets. Lastly, traditional utility providers must not be cast aside. They must be actively integrated as ledger validator nodes. This allows them to autonomously collect stable infrastructure wheeling fees through smart contracts while maintaining overall physical grid safety. That's all from our group. Thank you.